All right, so let's go over moles to mass calculations. Number 3. All right. Or number 2. I think on the page it says that, but on paper it probably says number 2. But the first one says find the mass in grams. Oh, find the mass. So which equation are we using? Mass is the blue equation down here. We got to find out that molar mass of that substance. So we have, let's put it up here, 7.53 moles of potassium. So in order to do that, then we got to know what's the molar mass of potassium. Well, there's 1 potassium times his mass is, I think, 39. Yep, 39. There's only one of them, so that's 39 grams of potassium per 1 mole of potassium. Then we go to the other side of the equation and go, I don't have 1 mole. I got 7.53 moles of it. So 7.53 moles of potassium. We want to know X grams of potassium. So from there, cross multiply. So I go X times 1 equals 39 times 7.53. So type that in, and you should get, oops, let me go over to my answers. Makes this fun to type them in. So I'll multiply that out, you get 294. X equals 294. And that was grams of potassium. So there's the answer for that one. So you had to first of all find out that molar mass of potassium. Then you put that in the spot where the double question mark is per 1 mole. And then you have, well, we don't have a full mole. We got 7.53 moles of it. And then solve for X. All right, well, let's move on to the next one. All right, next one, we're still doing the same idea. So we have, find the mass in grams of each one. Oh, okay. So I'm like, wait. There it is. So we have 2.67 times 10 to the negative 3 moles of C20 H42. Woo, that's a big molecule there. So we got to find out the molar mass of this one. So there's 20 carbons times 12 plus there's 42 hydrogens times his mass is 1. So you multiply this guy out, you're going to get 240 plus 42, so that's 282. So we're going to put that 282 in double question mark. So that's 282 grams of C20 H42 if I have 1 mole of C20 H42. Then I go to the other side of the equation and go, I don't have a full mole. I get this really, really small mole. Now, remember that's small because it's really times 10 to the negative 3rd. So we have 2.67 times 10 to the negative 3rd moles of C20 H42. And the top is X grams is what we're trying to find out. So cross multiply, we go X times 1 equals 282 times 2.67 times 10 to the negative 3rd. So now we type this into our calculator, go 2.82 times 2.67 exponent negative 3, and then hit enter, and you'll get an answer of X equals, you're going to get 0.753 grams of C20 H42. So a really small amount of grams because we really have a really small number of moles of them. So it's a very small amount of that 282 normally. All right, now we go on to letter C for this one. So letter C says we have 0.0391 moles of K2CO3. So we have 0.0391, and that's moles of K2CO3. So again, first thing we gotta do is find out the molar mass of this guy. So we gotta go 2 times the potassium, which is 39, plus there's 1 carbon times his mass is 12, plus there's 3 oxygens times his mass is 16. Add those guys up, so this is what? 78 plus 12 plus 48. So that's like 138, I think. Let's see, yep. So that's 138. So we have 138 grams of K2CO3 if I have 1 mole of K2CO3. Then I go back up here, no, I don't have a full mole. I got 0.031. So I got 0.0391 moles of K2CO3 And we're trying to find out X grams of that guy. So cross multiply X times 1 equals 138 times 0.0391. Type that guy into your calculator, and X is going to turn out to be 5.40 grams of K2CO3 is my final answer. That includes number 1. So now we're going to number 2. Number 2 says calculate the mass in grams. Oh, calculate mass. So we're still talking about that blue equation there. If we got 1.70 moles of each one of these guys. All right, so we got 1.70 moles. And the first one, we have sodium sulfate. Oh, sodium, that's Na. Sulfate, I gotta go back to that polyatomic ion chart. Oh my gosh, you gotta dig that out again. Yep. So we gotta go back and get sulfate, which is SO4. Then you gotta do charges. This guy's +1. SO4 from the polyatomic ion chart is -2. Those don't cancel each other, so I gotta crisscross that. So I get Na2, SO4. Now I can do my molar mass of this. So it's 2 times 23 for sodium, plus there's 1 sulfur times his mass is 32 from the periodic table, plus 4 times 16 for the oxygen from the periodic table. Multiply these out, that's 46 plus 32 plus 64. Add those guys up. I'm going to get my cheat sheet out. So that is 142. So 142, that's grams of Na2SO4 per 1 mole of Na2SO4. But then I don't have well actually I have more than 1 mole. I got 1.7 moles. So I got 1.70 moles of Na2SO4. And we're going to try and find out X grams of that guy. Let's cross multiply X times 1 equals 142 times 1.7, almost 2 of them. So you multiply that out and you're going to get X equals 241 grams of Na2SO4. So there's my answer for that one. All right. Now we're going to the next one. I'm going to leave that 1.70 because that's what we're working with. But now we're going to end up changing to a different substance. So in order to be, there he is. So this time we've got iron hydroxide, iron 2 hydroxide. So iron 2, that's Fe, the 2 means he's +2. Hydroxide, oh that's on the polyatomic ion page, which is OH, and that's a -1. Now those don't cancel each other, so I gotta crisscross them. You gotta put this in parentheses and make that 2. Alright, now I figure out my molar mass. I got 1 iron times his mass is 56, I think, yep. Plus, I got 1 oxygen times 16, plus 1 hydrogen times 1, and all of that times the 2 that's on the outside. So that's 56 plus, this is 17 times 2, so that's what, 34? So you add that up, that's 90. Yep, 90. So 90 grams of FeOH2. If I have 1 mole of FeOH2. If I don't have 1 mole, I got 1.70 moles of FeOH2. Now I want to find out X grams of that. Cross multiply, that's X times 1 equals 90 times 1.70. So I got more than 1, so it's going to be higher than 90. So you multiply that out, X is going to turn out to be 153 grams of FeOH2. So there's the answer for that one. All right, that takes me to question 3. All right, we're going to find the number of moles in each one of these. Number of moles. There's moles in both one of these equations, but remember I told you before, don't use moles to guide you as to which equation you use. You got to use what else they give you. So you look at letter A and it says we got 2.40 times 10 to the -1 grams of boron. Oh, there it is, grams. So we're talking about this guy. So we're going to use the blue one, 2.40 times 10 to the -1 grams of boron. So if I'm doing grams, I got to do molar mass of boron. So I got 1 boron times his mass is 11. So its molar mass is 11, so there's 11 grams of boron if I got 1 mole of boron. Well, and I don't have 11 grams, I got 2.40 times 10 to the negative 1 grams of boron. We want to find out X moles of that guy. So notice that my grams are on top, now I got X on the bottom because that's where the moles are. Cross multiply, so we get 11 times X equals 1 times 2.40 times 10 to the negative first. Then I get X by itself, so divide by 11, divide by 11. That gets that out of there, and I got X equals, and let's see what it equals. So it ends up equaling 0.0218, and that was moles of boron for that one. All right, we got enough time. We're gonna do one more before I have to stop because of my time, and we'll go on to part number 2. All right, so letter B says we got 18.3 grams of titanium oxide, 18.3 grams of TiO2. All right, so again, we're using grams, so we're going to use that blue equation. So we got to find out its molar mass. So there's 1 titanium times his mass is 48 on the periodic table, plus there's 2 oxygens times his mass is 16. So we've got 48 plus 32. So that's 80. So we got 80 grams of TiO2 if I have 1 mole of TiO2. But I got 18.3 grams of TiO2, and I want to find out X moles of TiO2. So cross multiply, 80 times X equals 1 times 18.3. I get X by itself, so divide both sides by 80. So X ends up equaling, if you type that in, you're going to get 0.229. And that was moles of TiO2. So that's my final answer on that one. Let's see, actually looks like we have enough time. Let's do letter C. So letter C, we got 437. So we got 437 grams of NH4 2CO3. Should get that right. Yeah. All right, so again, we're doing grams, so we got to do the molar mass on this. So there's 1 nitrogen times 14, plus there's 4 hydrogens times 1, and all of that times the 2, plus we got 1 carbon times 12, plus 3 oxygens times 16. So we'll add these guys up. We got 14 plus 4, all that times 2, plus 12 plus 48. So this is 28 times 2, so that's 56 plus 12 plus 48. Add those guys up and you get 96. So this is 96 grams of NH4 2CO3. And that's if I got 1 mole of that guy. Well, actually I have 437 grams of NH4 2CO3, and we want to find out X moles of it. So cross multiply, we get 96 times X equals 1 times 437. Get X by itself, divide both sides by 96. And X ends up equaling 4.55 moles of NH4 2CO3. Oops, let me move that down. I see it's not quite on the screen. There's the answer, 4.55 moles. All right, that concludes this. We're going to go on to part number 2 to do the last one because I'm out of time.